Alright guys, so just to work through a couple of examples dealing with what we went over in the last video. Alright, so first we got two complex numbers, z1 and z2. Note that z1 is in polar form because it's got your r, which is your modulus, and then it's got the cis and then the argument right there, the angle. And then here you've got Cartesian, which then has your real part and your imaginary part. Okay, so the first thing it wants to do is take z1 and express it in Cartesian form. And then the second part wants us to take z2 and express it in polar form. So let's go ahead and do that. Let's take z1, which is equal to 3 cis pi over 6. So what does this mean? Well, that means that I'm going a distance of 3 at an angle of pi over 6. And so I can draw that out. Pi over 6 is somewhere over here, and it's a distance of 3, right? So I got my correct angle, pi over 6, and then I got my direction, which is 3. Now from that, I can figure out what the real and imaginary components are, right? Because I know the ratios of these sides should be 1 to square root of 3. So if this side is 3, that means that the vertical side should be half of that, so that should be 1.5. And then this, of course, or you could do 3 over 2, right? And then this, of course, is root 3 times that, so 3 root 3 over 2. And this allows me to then write z1 in Cartesian form, because all that is the real part. The real part is the x-axis, which is 3 root 3 over 2, plus the imaginary part, which is 3 over 2. And so there you go. Now you've got it in the polar form, or sorry, in Cartesian form. So now what we're going to do is we're going to take z2, which is in Cartesian form, and we're going to try to write that in polar form. Okay, so again, we take our drawing and we say, well, that's 5 in the real direction and 5 in the imaginary direction. So I go 5, 5, and that puts me right here. So what do I need for polar? Well, I need the modulus, which is the length. So if it's 5 and 5, then I just go 5, so I go the modulus, or the length of z. So that's 5 squared plus 5 squared, and then square root, a squared plus b squared equals c squared. And I end up getting that the modulus is the square root of 50, which is 5 root 2. So now I've got the modulus. Now the other thing that I need is the argument, the angle. And so to get that angle, well, the two sides are the same, which means that has to be 45 degrees, or pi over 4. And so I can write z2 now in polar form just by saying 5 root 2 cis pi over 4. All right, so no problem. Easy stuff, right? So now what it wants us to do is calculate z1, z2 in both Cartesian and polar forms. So what it wants you to do is essentially see which one is easier and just kind of get some practice with the mathematics of both ways. So, you know, let's do the polar first, because it's easier. And so remember what we learned in the last video is if I do z1 times z2, then the result is just r1 times r2 times the cis of theta 1 plus theta 2. All right, and that's what we proved in the last video. So if we go through and do that, then looking at the polar coordinates, the polar coordinate for z1 was 3 for r1. R2 is the modulus here, so 5 root 2, and then cis, and then theta 1 was pi over 6, and theta 2 is pi over 4, right, taken from the argument there. So I'm adding the arguments together, and so I end up with 15 root 2 cis, and if I do a common denominator of 12, that will be 2 pi over 12 and 3 pi over 12, so 5 pi over 12. All right, and so that's essentially my answer. All right. Now, if for whatever reason I needed to find out this, I can actually do that, right? Except I don't really need to worry about it right now. It is going to ask me to find sine, cosine, tangent later, but we'll worry about that here in just a little bit, okay? So let's go ahead and let's do the Cartesian now. So if I'm going to do z1 and z2 in Cartesian, that means I'm going to have to take 3 root 3 over 2 plus 3 halves I, and then I'm going to have to multiply that by 5 plus 5I, and essentially that means I'm going to have to distribute and do some work there. So we'll go ahead and distribute. That gives us 15 root 3 over 2. Distribute to the other one. That gives me 15 root 3 over 2I. And then we distribute this one, so plus 15 over 2I. And then plus 15 over 2, but I times I is -1, so that will just become then a minus. Okay, we put together the like terms, so then we've got 15 root 3 minus 15 over 2, and then plus 15 root 3 plus 15 over 2I, just like that. And so now I've done it in Cartesian form. So we got answers both ways. Which is easier? Well, that's for you to decide. But note that this one is not given to you on the IB exam. You just have to know that or memorize it or be able to work it out. Okay? So the next part is finding the exact values of 5 pi over 12, cosine of 5 pi over 12, and tangent of 5 pi over 12. So what I'm going to do is I'm going to show you sine or cosine. It doesn't really matter. Let's do cosine. It's in the middle. So let's do cosine of 5 pi over 12, and then I'm going to leave it to your imagination to be able to figure out sine and tangent because they're essentially the same thing. Alright, so we say cosine of 5 pi over 12, right, is equal to x over r, right, because if we're thinking about 5 pi over 12, you've got your x component there, adjacent over hypotenuse, where this is r, x, and y. So, why it keeps doing that, I don't know. My pen's going crazy. So, equals x over r. And we know that the x value is the real part here. So that would be 15 root 3 minus 15 over 2. Right? Note that the y value here is the imaginary. Remember, this is still imaginary and real. It doesn't change going from polar to Cartesian or back. It's still the imaginary and real. So there's your y value. There's your x value. And r, of course, is found from your polar coordinates, which is why it says hence, because it wants you to use the r from your polar. So divide by 15 root 2. And so take that from the polar and take your x and y then from your Cartesian. And so we can simplify, put those together. So we end up with 15 root 3 minus 15 over 30 root 2, which of course then simplifies to root 3 minus 1 over 2 root 2. And it's fine like that. If you want to multiply top and bottom by root 2 to get the radical off the bottom, you can. But essentially, there you go. That is your cosine of 5 pi over 12. You do similar things for sine and tangent, but like I say, I'm going to leave that up to you and your imagination because I got other things to show you. So we're going to do one more question right here. We're going to do a division one, since that was the other thing that we looked at. This is actually going to be really easy and straightforward. Again, I'm actually not, let's go ahead and do A. So remember z1 over z2. When we worked that out, it ended up giving us a formula that we can use, which was r1 over r2, or times 1 over r2, and then cis theta 1 minus theta 2, right? So very, very similar to the multiplication. In fact, you probably want to memorize one of them and know how to get the other equation from there. So division, you're going to divide the r's and subtract instead of adding. And so for this first one, you've got r1, which is 6, r2, which is 2. So you've got 6 over 2, cis, and then the angles, angle 1, 75, minus 20. So pretty straightforward, 3 cis 55. I don't even know why IB Book would have that question, other than just making sure that you're practicing that idea, which is why I was going to skip it and just decided not to anyway. So now we've got the same thing right here. This is exactly the same because remember 8 is your argument, or sorry, not your argument, your modulus. 4 is your modulus, so r1, r2. And this is your argument. Remember, it doesn't matter if it's in cosine or sine and sine, or if it's in this cis format. That is then your argument of z1, and this then is your argument of z2. And so having that, you can then do exactly the same thing. We say z1 divided by z2 equals 8 over 4, r1 over r2, cis theta 1, which is 5 pi over 7, minus pi over 3. Common denominator of 21, so this will be 15 pi, this would be 7 pi, and so we end up with 2 cis 8 pi over 21. And there you've rewritten it. Okay, most of your homework tonight is going to be similar to that, just kind of reworking, dealing with the arguments, dealing with multiplication, dealing with division. Again, the whole purpose of this is to prepare us for the theorem that we'll be using next class. All right, good luck.